So today we've got Dr. Roger Flood from Stony Brook University over in New York. And Roger got intrigued by hydraulics and sediment transport, as well as bed forms in sandy sediment as an undergraduate at MIT. He spent a summer at Hawaii and learned about the wide range of sedimentary features in the deep sea, including the poorly understood lower continental rice hills, which were one of the prominent features on Mary Clark's drawings of the seafloor. Roger went on to get his PhD in marine geology at the MIT Hawaii Joint Program in Oceanography in 1978, and then did a postdoc year in England at the shallow water branch of IOS with Keith Dyer. At IOS, he learned more about sediment transport and bed forms in coastal environments, and then went on to Lamont Doherty to resume his deep sea activities. At Lamont, Roger had two cruises in the late 1980s using the RV Contra's new 16-beam multibeam system to study channels on the Amazon Basin and sediment waves in the deep sea. In 1988, Roger started working at Stony Brook University on Long Island, New York, where Larry Mayer and Dale Chase worked with him to convince ONR to buy an EM3000 multibeam system, which has been used in maybe as many as 50 deployments. Many of the projects undertaken have supported New York DEC and other agencies in their management of the marine and freshwater environment, and helped to provide Roger an evolving understanding of seafloor process. So Roger has offered to stick around after the talk for a little bit if anyone wants to get familiar with him and with the work he does over there. So feel free to stick around after. We'll do that in here. But otherwise than that, Roger, you've got the floor.
Okay, hello, Brandon. I assume you can all hear me.
Yep.
Yes.
Yay! So thank you for the introduction, and I'm glad to be there virtually and tell you a little bit about the kinds of things I've been doing at Stony Brook. I actually realized earlier this year that it's been about 50 years since I did my first oceanographic cruise, which involved side scan sonar and sub-bottom profiling off Nova Scotia, of all places. In any case, a lot of things have happened since then, and I wanted to tell you a little bit about the kinds of projects that I've been involved with in the last couple of years. So as Brandon said, we did with the, I was not the initiator, but Chuck Nitrower, who was at Stony Brook, and Larry and Dale Chase, and all got together and said, hey, we should be getting one of these shallow water multi-beam systems in the academic community. This was in the early mid-90s, I guess, late 90s, when these things were just becoming available, and it seemed like a great idea. So we worked on that, and it got awarded. And since we own the system, we can use it as part of projects. And New York has a big coastline with Great Lakes, Hudson River, Long Island, and the Atlantic, and we were able to convince some of the environmental agencies that they needed our help to better understand what the bottom of what these environments look like, so they can get involved some better management. All right, so let me see if I can figure out how to get this started. So as we started to work in the Hudson River, some of our earlier projects, we discussed with the captain what we wanted to do. And the captain said, you mean I'm supposed to drive outside the charted region, go outside those buoys and places that are just blank on the chart? And we said, sure, that's the plan. And so that's worked pretty well. A lot of our work has been done using this 28-foot boat, the Pritchard, and for some reason we seem to end up working in the winter. So there's snow on the dock, and we've got ice on the water there, and our Christmas lights displayed. It makes for some short survey days, and it's very much a hands-on operation that we do our own installation and operating. So here the transducer is getting bolted onto the bottom of the hull, and our propeller there shows that not everything works really well when you are outside the charted zone. So we had a few dings in the propeller, but all in all, it worked out pretty good, and we've been able to make some. We've done a lot of surveys, and I wanted to share some of that information. I'll just show a few examples. Here's in the early 2000s, we did some work around the Shinnecock ebb tidal delta on eastern Long Island, and saw its shape and started to get an idea of the change in where the sediments were accumulating on the delta. And then as NOAA has done more surveying, we've been able to take advantage of use some of those NOAA charting surveys and integrate it with our earlier data. So we can see here a difference map from about 12 years showing several meters of sediment accumulating around the edge of the delta, because we did the early survey and NOAA did the later survey. So this gives us some insight into how sand is moving along the coast. There are other things we've seen along, and these up in the corner there, those blue irregular things are polychaete mounds. This polychaete acebelides grows up in these mounds, and it makes topography about 1 meter high that's common in some settings. They move around a lot. They're not predictable in terms of where they are, but they're a organism that grows up over the winter, so they're right at in the late winter and early summer, and they're actually a good food source because they're there when there aren't too many other things growing. But this is a kind of serendipitous thing we can find and follow up on that gives some idea of how the seafloor is varying with time. And here's another example. This is two little surveys done off the south shore of Long Island, where there are some outfall pipes, sewage outfall pipes, and the state wants to increase the volume, and so they organized a project to look at the impacts. And part of that, of the existing system, part of that was to do these surveys and create these backscatter maps showing that the patterns on the seabed seem somehow to have been affected by the presence of these outfalls, and then others were able to sample all these patterns and understand how the biota was distributed and what kinds of organisms were living in these places to help with the design and regulation. And the picture on the bottom shows a side scan image of these diffusers that come out of the seafloor and a sort of a cleaning box that's there. And one of the trawlers hit that cleaning box, and it started to leak. So the water, instead of going all the way down the pipe to the diffusers, just came out of the middle. And so we were a little uncertain to what was going on, but here's a water column image that we made driving our multibeam system along that length, and we picked up very nicely that the image of the water coming out of the clean out box and coming up, so we could see exactly where it was, and so divers could go down and understand the problem, and then they could be designed in such a way that it wasn't quite so susceptible to damage. But one question came up that sort of related to nautical charting is that the chart doesn't show the concrete box and those pipes coming out of the bottom as any kind of something that would interfere with a fishing survey, a hang or some kind of hazards that are often indicated on charts. And so, so our dredging community just drives right over these things, and they can cause some damage to them and the equipment. But in any case, we were able to use our technology to demonstrate what the problem was, so it could be fixed correctly. So we've had this system since 1989, and here's the best list I can make of the kinds of surveys we've gotten involved with. And I think I got about 50 deployments over over this time period. And some of them are as I said, for sort of environmental management kinds of purposes where the state has an interest in understanding how to regulate the environment it's responsible for. And those included things like a survey of the entire Hudson River, which took a couple of years, 2 weeks at a time. And so at least then the state ends up in a position where they know as much or more about the environment than the consultant does, who brings in some plan so the state can manage intelligently. And so there are a number of projects like that. Some are more science oriented, including somewhere in here is a trip to Turkey, where we looked at the flow into the Black Sea, which was quite neat. And having been an oceanographer during all the time when it was very difficult to get into the Black Sea and you were restricted from being in certain parts, it was really a treat to be able to work there. It almost seems that those wide open spaces of the Black Sea are maybe not there anymore. So, but we had a good trip. I also learned about the regulations related to shipping things like motion sensors around the world. But there's been a lot of activity. We've had students involved. As I say, we're putting the thing together. We're working with the data. We're fixing the problems, more or less. And so we really get a hands-on experience with the system. So in all these surveys, we see a lot of things, as all of you do when you're out seeing the data spew out of a multibeam. And so as part of this talk here, I wanted to try to make some sense out of sort of a portion of it that otherwise we might not follow up on. And that has to do with the impacts of Superstorm Sandy in this area. And that is related to our periodic surveys of fishing reefs, artificial fishing reefs around Long Island. And just for reference, in case you don't know, Stony Brook is pretty much where the Inn in Smithtown is on the north shore of Long Island. But so we've only been to these places about 3 times, but it started in about 2001. So that gives us a pretty long time frame to study. And what we've realized is, I put this together, is that we have sort of a story there related to Sandy and its impact in the coastal environments here. So these are places we've done work, and nowadays we can see this on the web, which are places that NOAA's been working, and they've been particularly active around Long Island. After all, it is Long Island is a major shipping route into New York City. Lots of barges go through there. And so it's really important to have good charts and a good understanding of the seafloor, and then around New York City and up the Hudson. And so we can take our sort of almost postage stamp type of surveys and put them together with the database of survey information that's coming along like this, and every now and then some other survey to actually get quite a few images of various parts of the seabed over time. And so we can take, let's see. All right, so what I was going to do is look at, see what our data has to say, and there's other surveys about Sandy and its effect on the seabed here. And I'm going to look at those areas with the blue circles, which are 4 of the artificial reefs, Atlantic Beach, McAllister Ground, Fire Island, and Mauritius. And then there are 2 stars, which are 2 other places I was going to at least mention. But this is, others have certainly been interested in and done a lot about the effects of Hurricane Sandy on the seabed. In particular, this paper here, Art Tremblay and Larry Mayer is also involved, and that did quite a bit of work around a fishing reef in New Jersey as Sandy came through the area. And so they get a very good description of what's going on in the area. And so we're not going to try to repeat that kind of thing, but we can take advantage of our long record and maybe think about the evolution over time, what's happened since then in terms of these settings. And so I'm going to start by going to the National Data Buoy Center and looking at this buoy in the middle of the apex, and getting the record from that, which has wave parameters, period, height, and I guess basically the period and the height and the water depth are the things that we need. And so I can got that information, and then I can take advantage of sort of those classic wave equations that we see pages and pages of, and go through. This is a 20-year data set from that buoy, and calculate the U0 max, and that's the maximum speed of the water as it moves back and forth right near the sediment surface. So if the water is too deep, or the wavelength is too short, I guess, then it's a deep water wave, and there's no motion at the seabed, so there's velocity is 0. But if the wavelength is less than twice the water depth, then there should be some motion, wave-related motion at the seabed while the waves are passing over. And so you can use these equations and come up with this U0 max that's what I've done here. And so the many buoys, at least I checked 2 buoys, and they gave pretty much the same wave height record. So I took this one height record, and I crunched through it, and part of the calculation depends on the water depth. So I made 3 plots here. The top one is what the U0 max speed would be if the water was 18 meters deep, middle one 28 meters, bottom one 41 meters. And the numbers on the side are the speed in meters per second. So in that middle one, the maximum peak there is about 2 meters a second. So the water's going back and forth in the wave motion at I guess it's this way, 2 meters a second. So that's pretty brisk. And as the water gets deeper, that U0 max gets smaller. And so I'm sure there are much more sophisticated calculations that could be done, but I think this gives us some idea of what's going on in terms of interacting with the seabed. So we can see Hurricane or Superstorm Sandy is marked there on October 31, 2012, and in 18 meters, this U0 max should be as high as 3 meters a second. And it's down to 1 meter a second, I think it says. Yes, and even at 40 meters. So it's this is consistent with what others say. It's known that waves can cause part of water motion even at quite significant depths. I also marked Bill there. And so in August 2009, there was a Hurricane Bill. I guess it merged with the nor'easter, but it was quite far offshore. And so it didn't really cause any stir, but it did create some really big waves. And so there's quite a peak at where Bill is offshore. As I said, sort of late August 2009. But there's sort of you can sort of see a seasonality in this U0 max. And so regularly that gets up to 1 meter a second or maybe more a few times a month or a couple times during the year. So this is sort of the environment. And we don't really know much about which way these currents are flowing. We just know that there's there we go. Whoops, the other way. All right, so I'm going to go to this Atlantic Beach reef here, and we'll see what it looks like. So this is the classic Fledermaus image of this reef, and there's a sort of a wall built down the middle of it with a concrete rubble from a hopper dredge. And initially they made it too tall and it was violated their permit, so they had to cut it down. But so that's through the middle, and then there's a number of wrecks and barges and ice cream trucks and so on south of that bridge. And we have the sun illuminated or hillshade image and also the backscatter image. And we're going to look at I think there's six surveys that have been through this area over 20 years. And so we can get an idea of what the bed looks like. So in 2001, this is what we saw, a lot of little spots related to this debris on the seabed, and a nice set of some sort of sand wavy kind of thing off to the side there. And then the next one, 2005, we were back there, and those sand waves have moved a little bit. There's some kind of sediment deposit on the north side of that ridge. And then 2009, I think, is the next one. This is a NOAA survey. And in this case, this bed is not quite as smooth as 2005, 2009. Our sand waves, our ripples, sand waves, I guess they are still there, but there's a little more disruption. And I think this is about the time that Bill was out there and maybe did a little bit of erosion. So John Goff at Austin arranged a survey using the Seawolf in our system that was 2.5 months after Sandy, and we were back at this area then. And the bed is now quite a bit different. There's a lot of scouring in some places. Our little sand wave field is gone. On the north side of that ridge, you can see some pretty intense scouring has occurred because of this event. And so this is the kind of thing that was seen in New Jersey when they did their study. A lot of sediment has gone or moved around. So this is also in 2013, but later in the year, and maybe some of that sediment is deposited again. So it's smoothed out quite a bit. Our little sediment waves have come back, sand dunes, sand waves. And then 2019, we have a sort of a normal looking seafloor again with those little waves back and smoothed over. So it looks like in this case, maybe 6 years, somewhere between maybe on the order of 6 years or before 6 years to get back to a normal kind of situation. All right, so McAllister Grounds is quite close to that. And in this case, it's quite a bit sandier, slightly shallower. And these ridges are sort of a fine sand, and they show up as the darker backscatter, and they're on a gravel bed, which shows up as the more reflective seafloor. So we have a set of sand waves of some sort, or duney kind of things. They're sort of flat on a sediment-starved pavement, and you can see lots of little things on the bed there. Okay, so in 2001, we see, as I described it, there are several bridges. I should say these maps are all about 1 kilometer across. And people have commented how at this fishing reef, sometimes there's stuff in the bed, sometimes there isn't. Well, the answer is the sand waves are moving and they bury and expose things. The next one is 2005. Now they put additional materials there, more of this gravel dumped by a hopper dredge to create a little more habitat. And if you compare these two, there's been a little bit of movement of those waves, but not too much. And then this is right after Sandy, and there's quite a bit of movement here, and those regular waves have kind of broken up a little bit, got much more irregular, and they're right, they're not linear so much, but the waves have definitely moved quite a bit in those that time. But that is 2005 to 2013, so it's over 8 years. So we don't really have any rate information. This is a hydrographic survey in 2013, a little bit after Sandy, and we see a very similar picture, but we'd expect that if the two surveys are close in time. And then 2019, so between 2013 and 2019, the waves have sort of regularized again, gotten more linear, but they have moved a fair bit. So while they moved, it looked like probably during the Sandy event, they continued to move after that event. But things are getting back sort of to normal in 2019. So it looks like from what we see there, these waves, larger wave and shorter period waves, give you a higher velocity near the bed, have been moving or resuspending these sandy sediments, and once they've been resuspended, then if there's some movement in the water, it can move the sediments in some directions. So, and this is sort of dogma of shallow water sedimentology, that you can, if you can use the waves to get material into suspension, then the currents, whatever they are, can move the material along. So, so it looks like we don't quite know what's moving, what flows are moving it, but in both these cases, there's been sort of a northward movement of sediment. And I just want to show this again to emphasize that there's sort of annual, on a yearly basis, in the winter storms, I guess there can be events strong enough to move sediments up into the water column, and then if there are tidal currents, storm currents, wind-driven currents, whatever can move those sediments along. All right, so so we've got sort of a picture from those first two. So we're going to look at the three other areas along the Long Island there, and so here's a USGS map of the south shore of Fire Island along this place, and we can see those large oblique waves that cut through the area, and then the three things indicated are where we've collected some data. The two on either end are fishing reefs, and that thing called New Inlet is a survey partway through. And so we're going to look at these. There's and we start to see something different as we move over here. This is a side scan, multibeam backscatter image that we made, and so we see those regular ridges or waves. But what's unusual here is that very low backscatter is present in the trough. And when it's sampled, you get this very liquidy, recently deposited, unconsolidated mud in those troughs. And so we had a lot of debates over where this mud comes from and whether it's washed in from the shore or resuspended out of the bottom. A lot of sediments in the apex have a few percent of mud in them, even if they're sandy sediments, because we have the Hudson River delivering lots of material into the apex. But anyhow, so this is a pattern that's a little bit different, and I'm not going to talk about the movement of those ridges, because a lot's already been written, including by John Goff here, based on the results of this study. And so he used they had seismic profiling and so on, where they could look at the layering over the waves, and talked about the bed forms migrating, but really not much evidence of erosion here, certainly nothing like what we saw in Atlantic Beach kind of setting. So, so it's sufficient just to say that wherever we saw a wave, it looked like it was moving, or would be moved a little bit in the next time. What's here are so that red box is the outlines of the fishing reef, and there are three sonar images here. The one in the middle comes from that image I showed on the other last slide, and it shows a trough with a very dark low backscatter filling, I guess you'd say, but the one from 2005 doesn't show that, and the one from 2019, a few years later, doesn't show that. And there are actually a few more surveys done in this area, and I'm not going to show them, but I can tell you that a USGS survey in 2012, just before Sandy, showed no black filling in the troughs. And our survey and the USGS survey in 2014 shows it there. And I think there's a later one that starts where it starts to go away. But in any case, what we see is that by the time we get to 2019, at least in terms of backscatter, the seafloor looks pretty much the way it did before the storm. So there's an event, there's sediment depositing. Maybe it's eroded, maybe it's covered, we can't really tell. So maybe there's some kind of event deposit there, and then the modern processes, the normal processes come back and move material around. And the surface anyway looks the same. So it looks like there's an event and then an evolution back to a normal stage. All right, so we're going to move along to that second area I talked about. This is called the survey of the New Inlet, and I put a dot there because the chart, the file I was using didn't show an inlet there, but during Hurricane Sandy there was a breach in Fire Island that created something that's either called the New Inlet or the Old Inlet or the Wilderness Inlet. But it happened to form in a national park in what's called a wilderness area. So unfortunately, or fortunately, the Park Service said, well, it's a wilderness area. We can't do anything. We have to let it evolve. And so here we are, 7 years later, and the inlet's still there, and water still goes in and out, and it hasn't closed yet. But in any case, we did the survey here, and what we saw in 2013 was a little bit of mud in some of these troughs. It's not in everyone. It's not quite. These are slightly different form features, but there's still some mud there. But if this is 2013, here's a survey done in 2014, right in the same spot. And all the mud patches we saw in 2013 are gone, but there's a new set of mud patches, a little bit shallower water. And so this is even more peculiar. So somehow the muddy sediments that deposited in the trough either got resuspended or buried, and new mud came in, or the same mud moved over or something. Anyway, there's something happening there on a time scale that's shorter than a Sandy kind of event. And we saw plenty of sort of annual events that could resuspend sediments. So we're getting a feeling for that this kind of thing can happen on a fairly regular time scale. And it may well be that the Sandy episode got a lot more fine-grained sediment in the system, which is now sort of just moving from place to place. All right, so I'm going to go over to this Mauritius ridge on the end. There's actually another survey beyond that, but in any case, it's on the end of this patch. And there we see something that's similar, but maybe different. So the north half of the picture is the sun illuminated or hill shaded image where you can see the debris of the artificial reef, and with the linear waves and the very sharp troughs. But the backscatter image that goes with this shows again a very muddy, must be, we didn't sample it, muddy patch in one of these troughs, and it's really only in that one. So, well, what's that doing here? How did that get there? There are lots of dark dots on this, but we know what they are. They're fish, schools of fish in the water column, and we had our water column data being recorded, so we could tell that they were indeed fish that were messing up our our backscatter image. And if you look on the top image where the mud is on the bottom image, you can see little lines going southwest, northeast. And those are the marks left by surf clam dredges as they drag across the bottom looking for surf clams. So, the dredges have been able to go through this material, whatever it is, and it's rigid enough to leave a mark in the surface. So again, something slightly different. This is this is 2019, so we're 6 years after the event, and there's still mud going around. So it's not from the event, but it's from, maybe it's related, maybe it's not. It's very curious. All right, so that's about where the story ends right now, in that we'd love to get lots more surveys, but doing it the way we're doing we have to do something more particular. This might be an ideal job for the AUV kind of thing, where you wind it up and go tell it to survey once a month, and really start to see some temporal variability and relate it to the conditions out there. But we've been trying to understand how, at least for some of these more or less routine surveys, we can take the results, combine them with other kinds of things, information out there, and get a better understanding for this longer term evolution of the coastal environment. So often, I mean, we know it's not true, but if one's charting or doing something like that, you say, well, okay, I did the survey, I checked the box. We don't need to know anything more. But for the environment, we really do want to get a better understanding of what the processes are, what what's going on, how things are changing, what's normal, what's abnormal, and so on. But I think what I've at least got educated here about is the fine-grained sediment dynamics and storms in the coastal waters here off New York, and getting a better idea of what their impact is and how we might have to think about them. All right, so I think that's the technical bit, and I think I have one more part to this, is more of the advertising bit, in that one of the projects I've been involved with every now and then, it has to do with understanding the seafloor between Long Island and Connecticut. It's not a federal water body. It's controlled by the states on either side, more or less. But there's lots of interest in, and there are some cables and pipelines that run across the sound, and the environmental regulators, especially on the Connecticut side, really want people who are going to put in these structures to do it in sort of an environmentally sensitive way. Don't put a pipeline through my all my suspension feeding corals. Try to go around them, please. So they were trying to learn a lot about the habitats in the Long Island Sound, so that as new projects get proposed, the people who propose them can design them initially in a responsible manner, so that you don't get into an argument about, no, I'm not going to move my pipeline after the fact. So anyway, so this has been a wonderful opportunity. We're going to buy a new Multibeam Kongsberg system that will really upgrade our EM3000. I've learned a lot about keeping Sun Ultra 2s running for long past their expiration date. And so that's going to be a great thing. And we've got the opportunity to actually hire a person who can really get involved with this new system help to make it run and keep it running. It's not an onerous sea growing operation, but there's lots of data, and as we all know, one has to work on it and make sure it's all good. So anyhow, this got posted earlier this week, and the deadline is 1 month after it was posted. So that's my great fun, and I'm glad to advertise it to anyone who wants to know. And this gives you a hint of what Long Island Sound looks like. The green and orange areas are places that have already been the focus of this Long Island Sound habitat study. And there's a third area, which I think is that yellowish color on the western end. And then there's some gaps in the middle. These are places where NOAA says, thank you very much, but we have enough information about what's on the seabed for our charts. We know they're going to be accurate. These have all had 100% side scan and so on. And so there's no charting problem, but for environmental purposes, we want the much higher quality data. So that's the initial assignment. But once we have this equipment in hand, as we saw from my very long list before, that's really a lot of opportunities to pursue and get in projects and have some fun, as it were, with the system. So anyway, I'll stop there and see if anyone's still there. There's some questions. Thank you.
Roger, thanks. This is Larry.
Oh, hi, Larry. Hello.
Really interesting talk, and I got to just give you amazing credit for keeping that EM3000 working for all these years. And that's really miraculous. A real credit to you. I had a question about the fine grained sediment, and you imply that they're being brought in from somewhere. But is it conceivable? I know it kind of sounds non-intuitive, but is it conceivable that they really just represent the substrate that's being exposed? And I asked that because in Martha's Vineyard, we found that in the supposed ripple scour depressions, which aren't really, but we found that indeed after the storm events, we often had exposure of finer grained sediments. And then with time, the coarser grained sediments migrated over. And so have you ever had a chance to look, take a core, look at something on them? Is there potentially a muddy substrate down there? Very fine grained substrate. You said it was cohesive enough to maintain a dredge scour. So
well, there could be. It's a big place, and I know on the New Jersey side there are I think there are actual rocks and so on, I don't really know that much about it, but that is something that could be going on. That there's that there are local sources. I mean, the Hudson itself, it can be a huge source of sediment. A lot of that flows down the New Jersey side initially, but so yes, that's something I shouldn't be ruled out, right?
Roger, John HC, amazing changes you're showing there, but you show it mainly as the morphology, the bed forms moving. And I know that's 20 years of surveys, and you're quite a way offshore, some of those. What sort of confidence did you have in sort of, if you were to snap a difference between those surveys, would we learn something, or would we just learn that we're not that good at positioning, particularly vertical?
Well, one feature, I guess, of working on fishing reefs is this: somebody's thoughtfully put down all sorts of stuff on the seabed, and so as you do it, at least for horizontal positioning, if that wreck is in the same place this time as it was last time, you can have some confidence over that you at least got the positioning right. But it's, I mean, it's definitely true. We've gone through the beacon receivers and all that kind of stuff over the years, and it's but I think, I mean, it's certainly something to keep in mind, that there are potential inaccuracies, and every now and then it's really interesting when you put all these surveys together. Some of the wrecks do rotate. That's sort of curious, by 5 or 10 degrees. They're pointing different ways. So I don't know how that happens, but there are. But I think some of the features we're looking at are large enough to not be affected by that.
Okay, Roger, Larry again. I think it was the Atlantic Reef survey you showed. I don't know if you could flip back to the slides. I was intrigued that the bed forms you had were in such a narrow sector, and jumped across.
Yeah. So the
jump across the reef. So I'm just wondering what's happening. You look like you got a jet or something that's just really narrowly constrained there, or is it just that's the only place where there's mobile sand?
Well, there is topography, sort of a topography like those large sand wavy things are present here, and I think there in this image you can see the lows. And so in part, I think the waves are in those lows, and the reef designers, the guy over at DEC who drew the line of where it put it, he said, "I wonder if this is going to block off sediment transport. That'll be interesting to see." So yeah, I mean, we're curious. I always look at this one and the other one where they put these gravel, dump these hoppers of debris to try to get an idea if how they're impacting the flow. But yeah, so in this case, it may be that the topography is doing enough to control the flow so that it hits this little bump. And I guess I should know offhand how tall that is. It sort of goes right over. And
I hadn't realized that it was correlated to that trough, so that makes a lot more sense.
Yeah, and then so in this one, there's sort of a little sand wavy kind of thing just on the north side there. So maybe some sediment gets over and then it moves sideways. What I should be doing is hiring people who want to, not hire, but convincing divers. People dive on these things, to catch fish and lobsters and all that stuff, and convince them to go and swim around and video everything and tell us what's down there. For a sedimentologist, I don't take too many samples, enough samples.
Well, hi, Roger. I'm Brandon here. I've got a question for you. What's the depth of these maps that you're kind of showing us? And
okay.
Also follow up, just like what's the maximum depth you kind of notice bed form migrations out here?
So this one, I think I cheated. I wrote it down here, 18 meters. So that's about what these are. The fishing reefs need to stay pretty, or mostly are within the 3 mile limit. They have a couple that are out to 12 miles, but mostly they're within 3 miles. But so sort of, I think anywhere where you, in the maps you see wave-like bed forms, it probably means that there's sediment transport. And so certainly out to 40 meters. One nice thing about these wind farms, there's a wind farm being, I guess, actively pursued in the apex, is that there's a lot of mapping that's going on. So when NOAA does it, they end up on their website, and there's lots of bed forms out there, even out to 40, maybe 50 or more meters. as you get closer to the shelf, other things start to happen. Flows accelerate as they go from shallow to deep water, and we're getting out closer to where the Gulf Stream is, and maybe there's some eddies every now and then. And so other things start happening as we get into deeper water that keeps it active.
Yeah, thank you.
I have a question.
Andy?
Yeah, Roger, it's Andy Armstrong. In your repeat surveys, are you seeing any general trend towards deeper or shallower? Or are you just seeing the depth sort of varying around some mean?
So I haven't focused as much as I should on what the depth is. We've gone through many iterations of figuring out what our datum should be. We started out with the prior tidal datum, and every now and said, "Oh yeah, better add 0.9 meters to that." So there are some uncertainties. Again, those wrecks, some of them are quite prominent, barges and things. So they're sort of built-in markers. That Fire Island survey, one of the research projects in the 70s, I guess, early 70s, was they built a reef out of blocks, concrete-like blocks made from fly ash. And for a decade or two, they studied them and made sure they were not hazardous. But for the last 20 years, nobody knows where they are. They don't show up. So I think those large waves have migrated enough to bury them, and we just hope I'm around long enough to see the reef blocks come out on the other side. But there is some change in elevation as those things migrate, but they're moving quite slowly.
Roger, my name is Val Schmidt. I was really intrigued by your map showing the lows and backscatter due to the fish schools and how well they correlated with the artificial reef, the bits and pieces on the seafloor that were staying there. And I was curious about a couple of things. One, I don't know if we could look at that slide real quick, but do you see that kind of thing really commonly in the data sets that you've collected over the years, or was it very unique to that summer? And they were really persistent. I felt like
Get lost. Oh, there we go. Those?
yeah, that's fascinating to me. And like, I think you've
Well,
probably captured them in multiple survey lines, so they stayed there for a really long time.
Well, they were drifting around. Of all the reef sites we went to, it was only this one where there was a lot of fish. We had leased an EM 2040C dual head for this survey because my other one's just getting too old. But and so we did record the water column image throughout this for general interest. But this was the only one where there were a lot of these fish. I was hoping to see more of them.
Roger, we have a question in the chat from Jim Gardner. Jim asks, you implied that most of your surveys were done during the winter. Have you collected data during the mid to late summer to see if there are any differences in mean depth?
I think we've done surveys in the summer. So hi, Jim. Some of this, the winter just seems to be, a little delay, and all of a sudden September becomes January. And but I don't think we have picked out. Usually we see, if we do surveys at different times of the year in the same places, we get no anomalies like that. I keep hoping we'll stumble across someplace where all the organisms have died from anoxia, and we'll get a whole different pattern. But either we're not doing that, or I don't know what to look for. It's exciting that these new systems now are multi-frequency, and I don't know if that will help pick up patterns that are otherwise difficult to see with just a monochromatic sound source.
Okay, well, I think that's it for questions. So we'll give Roger another round of applause.
Thank you.